Dipole antenna design. One specific type of dipole antenna, which is planar dipole antenna design for GSM 900 application. For operating frequency is 0.85 GHz to 0.95 GHz. It will gives us a broadband, a large bandwidth as compared to simple vertical dipole antenna. The basic difference between vertical dipole antenna and horizontal dipole antenna is vertical dipole antenna radiate vertical polarized waves, and horizontal dipole antenna, which is planar dipole antenna, which generates or radiates horizontal polarized waves. Now we will design the planar dipole antenna, and finally we will discuss the result, and we will add the sweep in the result of parameters. So we can see by changing a parameter how the result are getting affected. First I am going to create a substrate which will be the box. Substrate, and I am going to add the material from a library which is Rogers with the relative permittivity is 2.2. Press OK and OK. Now I am going to add the parameters so that we can add the parameterized sweep in the result. This is we have position of substrate equation. Press OK. Substrate x-axis dimension is 212 mm. Substrate along y-axis dimension is 282 mm. Add these parameters to x, y and z axis. Now the height of this substrate is 2.1 mm. Press OK. By changing the height of substrate, you will observe the band is shifting as the patch value increasing. Press OK. This is we have the substrate. Now I am going to draw a rectangle for planar dipole. Now I am going to add the parameters so that we can add the parameterized result. Add these parameters. Antenna weight divided by 2, and for y-axis is port gap width divided by 2, which is 3.53 mm. Add these parameters for x size, antenna width, and for y size, dipole length divided by 2, subtract with port gap width. 142 mm is dipole length. For smaller frequencies, the length of antenna is larger, As compared to for higher frequency, the antenna dimensions are small. We will discuss these features in theory lecture of antenna design. You can check it on my channel. Now I am going to duplicate this one arm of dipole antenna on another side of axis, around axis. In around z axis 180 degree. Press OK. Now this is, we have the duplicate one. Now you can see this is, we have a planar dipole. Now I am going to create a port in between these two dipole arms. Add these dimensions as a parameters for a port of this dipole antenna. The values are already entered. Press OK. This is, we have port. This is, we have port that we have designed. Now I am going to assign boundary to this arm of dipole as a perfect T. Similarly for second arm as a perfect T. Now I am going to assign a port which is lump port as excitation to this dipole. From here we can check the pole has been assigned correctly. In between these two dipole. The purpose is to give an excitation. The substrate material has been assigned. Now I am going to create a radiation box to observe radiation in that box. Add these dimension for radiation box. Press OK. This is our radiation box. Now I am going to check the substrate is completely inside this radiation box. I am going to check validation check, analysis setup. I am going to add frequency which is 0.9 GHz operating frequency for 15 number of maximum passes. This is, we have a sweep value from starting position to end position. Press OK. Validate. It is OK. Now in next part we will see the result of this antenna, and we will add a parametric sweep in this dipole antenna. We will discuss the result changing with respect to change of substrate, with respect to change of dimension of dipole, increasing length or width of dipole,